Okay, let's take a look at the solution to bonus A of our assorted area problems. What we're trying to do here is find the area of, find the area of the yellow region, which is located down in here. And then we'll try to leave that in pi radical form. So the only clue that's given to us is we know that the length of AB, I'm going to highlight that over here, the length of AB is 20. And so what we have here is a bunch of squares and circles inscribed one another here. And if you're looking at what we're truly trying to find here is this little yellow shaded region in here, there's a lot of symmetry going on between kind of like the area is trapped between the green circle and the blue square. And so these four regions in here are all the same, and this long diagonal is actually chopping this little region into two pieces. So the strategy here to find our yellow piece is if you can imagine taking the area of the blue square, subtracting off the green circle, that would give us all four of these regions in here, but we don't want all four of them. We want really just this part, which is really 1/8 of the whole thing. Because if you can imagine, if that was chopped into two and that one chopped into two and that one, so it's 1, 2, 3, 4, 5, 6, 7, 8 regions. We just want one little yellow region out of all those created regions in there. So once again, let's start with A being 20, and we'll see where that takes us. But this is going to be our strategy. Blue square minus the green circle and divided by 8 because we just want 1/8 of the area trapped between those two shapes. So if that's 20, I see that this is 20, and this diagonal of the square, we would know that's 20 radical 2 because I see a 45 right shortcut in here. But what we want to do here is manipulate and draw some extra lines in, and hopefully you can see what I see. This line I'm drawing in right now appears to be what? It's half of a side, but not only is it half of a whole entire side, it's actually the radius of the larger circle, not the one that's green. That would be the one just inside the largest square. And so if I were to redraw that a few different ways, I'm going to draw it over here. This is the same exact length right there. And if you think about, if the side is 20 altogether, then this red portion has to be 10. So this red line here is going to be 10, and this one here is going to be 10. So this red line is serving as the radius of the larger circle, and this is the same exact red line in here. It's still the radius of the larger circle. Well, what type of triangle do we have now? Well, if you look carefully, we have another 45 right shortcut within this square. And so if I know that's 10, I can now figure out, let's use a different color, I can now figure out what the length of this blue little squiggly line is in here. And that's going to be the same as that length because that's a 45 right shortcut. So if I take 10 and divide it by radical 2, and I rationalize that denominator, that's going to give me 5 radical 2. So that's going to be 5 radical 2. That one's going to be 5 radical 2. So right now, it looks like I know the length of that blue line, the squiggly blue line, and that's half of the side of that blue square. So altogether, that would mean 10 radical 2. That would be the length of the side of the blue square. And if you're noticing, the length of this blue squiggly line is also the radius of the circle. So that would be 5 radical 2 represents the radius of the circle. So I think we're good to go because we have formulas that say, look, s squared, that would be the area of the squared. We have pi r squared, That would be the area of the circle. And then we just have to divide by 8. So let's just plug in those two values. The side of the square, we figured out to be 10 radical 2, not 5 radical 2. So when you take 10 radical 2 and you square it, it's going to be 100 times 2. That's going to be 200. And then over here, we're going to take 5 radical 2 and square it. And when we take 5 radical 2 and square that, that's going to be 25 times 2. What's 25 times 2? 25 times 2 is 50 pi. So now we just have to divide it by 8 and see what happens. Well, 8 does go into 200 evenly. 8 doesn't go into 50 evenly. So what I'm going to do here is knock all these numbers in half and see if that helps a little bit. That's going to be 100 minus 25 pi all over 4. That's one acceptable answer here. That would represent, again, the shaded yellow region in our picture. Okay, hopefully that helped. Tough problem.